Alright, so the next question is a timetables question. These seem to be becoming more and more frequent these days. So this one, the following are parts of rain timetables between Swindon and Coventry and between Coventry and Durham. So reading across the timetable there at Swindon, you can see that you've got buses leaving at 14:29, 15:29, 16:29 and so on. When they get to Reading, they arrive in Reading station at 1500, 1600 and so on. They stay there for a period of time before leaving and heading off to Coventry, and the time they get into Coventry are written below. So that's how the information is read. So the first one here, Denise catches the 15:29 train from Swindon to Coventry. So she's on this train. How long does the journey take? So she arrives in Coventry at 17:23 and she left at 15:29. Now when you're subtracting time like that, you can't do a normal subtraction because normal subtractions count in tens. What we've got here is time, it's in minutes. Without a calculator, the easiest way of doing it is just doing it sort of on your hands. So that's 29 minutes past 15 or 29 minutes past 3. An hour later it will be 29 minutes past 4. 2 hours later, well, it's less than 2 hours because that would be 29 minutes past 5. So it's going to be 1 hour, and then from what do we got? From, if it was 17:29, it would be 2 hours. So from 29 back to 23 is another 6 minutes less than an hour. 6 minutes less than an hour is 54 minutes. So that's going to be 1 hour 54 minutes. Probably easier for you to work that out than for me to try and explain it. B. John arrives at Reading station at 14:55. He travels on the next train to Coventry for a meeting which, including the walk to and from the station, takes a total of 1 hour 20 minutes. He then catches the next train to Durham. When does he arrive at Durham? Okay, so let's take that one step at a time. He arrives at Reading station at 14:55. So 14:55 means that the next train to Coventry is this one. Okay, he arrives at Reading station at 5 to 3, so he's waiting for that train. He travels on the next train to Coventry for a meeting which, including the walk to and from the station, takes a total of 1 hour and 20 minutes. He then catches the next train to Durham. So he travels on the next train to Coventry, so that means he gets into Coventry at 16:22. Okay, so let's write that down. Arrives at Coventry at 16:22. He goes to his meeting, and the time of the meeting and the walk to and from the station takes a total of 1 hour 20 minutes. So he's back at the station. 1 hour after that is going to be 1 hour 20 after that, sorry, is going to be 17:42. So he's back at the station at 17:42, and he catches the next train to Durham. So the 17:42, that's when he gets to the station. So he's missed that one, he's missed that one, he's missed that one, but he's there in time for that one. So he catches the 17:49 train, from Coventry, which arrives in Durham at 21:39. Okay, so with questions like that, you've really got to read every piece of information carefully, because it gives you vital knowledge that enables you to use the timetables. So just quickly again, he arrives at Reading at 5 to 3, so he can catch that earliest train on the timetable, which arrives at 3 but doesn't leave until 11 minutes past. That means he gets into Coventry at 16:22. He's then got an hour and 20 minutes in Coventry, so that's going to be 16:22, 17:22, and another 20 minutes makes that 17:42, which means he can catch the 17:49 out of Coventry, which gets him to Durham by nearly 20 to 10 at night. Question 12a. So these are statements that you either have to say true or false and then give it an example as an explanation as to why that's wrong. So all prime numbers are odd numbers. That's not true because 2 is a prime number. It's the only even prime number. Okay, prime numbers have only themselves and 1 as factors, that is, divide into them exactly, and the only even one that's the case is 2. If I know what 0.25 of a number is, explain how you can find out the value of the number. Well, 0.25, a quarter, is the same. If you know what a quarter of a number is, if you want to find out what the number is, you'd multiply by 4 to get 4 quarters, which would be the whole. So times by 4 is all you need to say for that. And then for part C, explain which of 3/5 or 65% is the larger. The easiest way of doing that would be to turn 3/5 into a percentage. And what you would do is multiply it by 100. Okay? 100 divided by 5 is 1/5, which is 20. So 3/5 would be 3 lots of 20, which is 60%. So 3/5 is 60%, so 65% is larger, because 65% is bigger than 60%. Okay. Probability. A red bag contains 3 discs numbered 3, 4 and 5 respectively. A blue bag contains 4 discs numbered 2, 3, 5 and 7 respectively. So let's fill that in first of all. Then, so a red bag, 3, 4 and 5. So 3 will go there, 5 goes there. And the blue bag, 2, 3, 5 and 7. 7 and 5 has been put on for you, so you need to put in the 2 and the 3 as well. In a game, a player takes 1 disc at random from each of the 2 bags. The score for the game is the sum means add, of the 2 numbers on the discs. And if you're not sure that sum means add, look at one that they give you. 5 add 4 is 9. Complete the following table by writing in the missing disc numbers and all the possible scores. So in here we're going to have 2 and 3 is 5, 3 and 3 is 6, 5 and 3 is 8, 7 and 3 is 10. 2 and 4 is 6, 3 and 4 is 7, 7 and 4 is 11, 2 and 5 is 7, 3 and 5 is 8, 5 and 5 is 10, 7 and 5 is 12. So those numbers inside those squares are all the possible outcomes we can get from playing this game. Find the probability that the score for one game is less than 9. Well, numbers that are less than 9 in this game is 1, 2, 3, 4, 5, 6, 7. So those are the possible outcomes that will be less than 9. So there are 7 of them out of the total number of possible scores, which is 9. No, it's not. 12. Sorry. In a game, a player wins if he or she scores less than 9. 240 people each play the game once. Approximately how many would you expect to win a prize? So this is saying in every group of 12 players, 7 are likely to win. So what you need to do is to divide the 240 up into groups of 12. So we do 240 divided by 12, which is 20. And in each of those 20 groups, you'll have 7 winners, which will be 2 lots of 7 is 14, so 140 winners. Number 14. Use the fact that 54 times 116 equals 6264 to write down the answers to the following. So 5.4 times 11.6. The answer is going to have those digits in, because it's exactly the same digits that's being multiplied together. The only difference is the decimal point is going to be in a different place. Now if you look here, what you're multiplying by is basically 5 times 11, which is 55. So whereas that is going to be, or the original is 6,624, because I know 5 11s are 55, the decimal point must be there. Similarly with this one, 54116, going to be the same. So we're going to be working with 6264. Now this time, if you imagine that that is half, 0.5, a half of 116 is going to be, well, if it was half of 110, it would be 55. So that's also going to be the 62.64. And then finally, if you're going to be doing 6264 divided by 54, your answer is going to be 116. We're just going to work out where the decimal point is going to go. So let's just check you're happy with that. If we're doing that divided by that, then our answer is going to be involving those digits. And if we've got 600 divided by 50, remember that you can cancel a 0, it's like dividing by 10. 60 divided by 5 is 12, so that's going to be 11.6. So with questions like that, the digits are always going to be the digits that are in the number fact they're giving you, and you've just got to then establish where that decimal point is going to be by estimating those numbers, making those numbers easier to handle. 5 11s, 55, so it's going to be in the order of 50, 60s, 62.4, and so on. Question 15 is a scatter graph. Okay, it's a graph. Well, let's work out our units. So on this axis, I'm going from 0 to 1,000 in 10 jumps. 1,000 divided by 10 is 100. So each little square in that direction is worth 100. In this direction, I'm going from 0 to 100 in 10 jumps. So 100 divided by 10 is 10. So in that direction, each little square is worth 10. So when you're plotting a scatter graph, you're putting crosses at the intersection of this pair of numbers. So number of customers 500 takes us across to there. Takings in thousands, 7,200. So there's 7,000. 200 is going to be 2 little squares up, because we've established they're going up in 100. 220 is there. 2,400. 2,400, there's 2,500. So work out where we're going now. We're going to go across 2 from there and down 1. Put a tick so you know that you've done them. 460, 5,000. So there's 5,460 will be there. 400, 4,600, 400, 4,500, 4,600, and 240, 3,000. So that will be there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, what type of correlation? As one variable increases, so does the other. That makes it positive. Draw by eye a line of best fit. So you want your line to be of a similar slope to the curves and a sort of similar number either side of the line. So I'm going to go with that. And then the final part, estimate the take-ins for a Saturday when there are 320 customers. So what you do is you read up your graph from 320. And it's always worth marking it on your graph to show the examiner that you're trying to do the right thing. And I think a reasonable estimate to that would be 4,000. So £4,000. Question 16. Draw an enlargement of the shape below using a scale factor of 2. Use the point A as the centre of the enlargement. Okay, so when they give you a centre of enlargement, you count the distance that you move to go from the centre to each corner, and then you multiply that by the scale factor. So to work out where we're starting here, to get from there to the start of the shape, we're moving 2 squares. So in the enlargement, we've got to move 4 squares. So it's actually going to start there. Then this side is 2, so in the enlargement will be 4. So from there, 1, 2, 3, 4 will take us to there. Then we're going to go to down 2, so down 4. 1, 2, 3, 4. Then to go from there to there, we've got to go backwards 2 and down 2. So we're going to go backwards 4. 1, 2, 3, 4, and down 4. 1, 2, 3, 4. And then we go back to the start. So when you're given the centre of enlargement, you've got to work out how to travel from the centre to the start of the enlargement. Are we going here, across 2, scale factor 2, across 4? Doesn't make any difference that it's touching the original. Okay, B. Draw a reflection of the shape below in the line x equals 1. So that's saying that the mirror is going to be along the line where the x coordinate is 1. That's the x coordinate. So the line x equals 1 is this one. Okay, so there's your line x equals 1. So the reflection means that it's touching the mirror there, so that stays put. That line there is 2 squares to the right of the mirror line, so it's going to be 2 squares to the left of the mirror line too. So there's your reflection in the line x equals 1. C. Rotate the shape below through 90 degrees clockwise about the point 2, 1. So ask the examiner for some tracing paper. Cover your shape with the tracing paper and trace your original. Put a little up arrow marker. Now we are rotating about the point 2, 1. 2, 1 is there. That means that when we're turning, we're going to hold the tracing paper so it pivots around that point. So we're going to put the nib of our pen at that point 2, 1. And we're going to turn it 90 degrees clockwise. Now clockwise is that direction. so that we're going to turn it quarter of a turn, which means that arrow is going to point to the right once we've got it in the right place. So 90 degrees clockwise about this point where we're pivoting. So we turn until that arrow is pointing directly right. So there you can see is where we need to draw our rectangle. So that's going from there to there and then down 5 there and there. Okay, now it's much easier with tracing paper. You're allowed to use it, so make sure you ask for it. Put the tracing paper over the shape, trace the shape, draw an arrow pointing vertically upwards. Work out where your pivot is, 2, 1. That's where you're going to hold your graph. And then you're going to work out when it's being turned, what can I expect that arrow to be doing? Because it's easier to work out with an arrow than it is with the shape. So once that's turned through 90 degrees in that direction, it's going to be pointing right. Okay, question 17. The product of two numbers, product means multiplied together, so we've got two numbers that when we multiply together we get minus 65, and when we add them together we get 8. Now the fact that one of them is minus means that one of them is positive, one of them is negative, because minus times a plus is a minus, and the fact it ends in a 5 means 5 goes into it. So how many times does 5 go into 65? It goes in 13 times. Okay, so 65 divided by 5 is 13, and 13 and 5 is 8. So 1 must be positive and 1 negative. So the two numbers are 13 and 5, and to make them add up to give 8 it's going to have to be negative 5 and plus 13, because 13 take away 5 is 8. So if we multiply those two together we get 65, minus times a plus is a minus, and if we add them we get 8. And sum means add. Question 18. Okay, this one looks a bit tricky. A square piece of paper is to be folded exactly in half and then folded in exactly in half again. The original square piece of paper can be folded in this way to make a square or an isosceles right-angled triangle. In each case, draw the lines on the original square paper shown below. So you've asked your examiner for tracing paper. Nothing wrong with using it for something else. Let's make a square. That's 10 centimeters. So if I go 10 centimeters that way, and rip it, there's my square. So what this is saying is that I can fold this in exactly in half, which would be like that, and then exactly in half again, which would be like that, and that will make a square. Okay, so to make a square we're going to fold it exactly in half and then into exactly in half again, and that will produce what we're left with, which is a square. To make an isosceles right-angled triangle, well, clearly we can't fold it in half that way, so the only other way we can fold a square in half is diagonally. So if we fold that in half, and then we have to fold that in half again, then that is going to produce a right angle triangle. There's my right angle, and that side are going to be the same length. So the way that we did that was by folding it along that diagonal and then taking that one and folding it like that. So that's what they wanted you to do there. Okay? And again, a bit of practical work in your exam. You've got your tracing paper, no harm in doing that. 18b. Find and shade the region of points within the rectangle that satisfy both of the following conditions. So this is a loci question. 3 marks. So you're going to be drawing 2 boundaries and then shading in the right region. The points are nearer to the line AB than the line DC. So if we go into find the boundary between that line and that line, it's where you cut the 2 lines, the angle between them, in half. So you get your angle measurer, your compass, put the corner, the point on A, which is the angle between the 2 lines, open it out, doesn't matter how far, mark, and then move your compass point to the first cross that you made, and then keeping the distance the same, repeat that. So that line there between A and that intersection is the dividing line. If you're on that line, then you are the same distance away from that line as you are from that line. They are less than 6 centimeters from the point C. So I want to work out now everything that is exactly 6 centimeters from C, which is going to be part of a circle. Compass time again. You're going to open your compass out to 6 centimeters. Put the point on C and draw an arc of a circle which is going to go through your rectangle. Like that. So everything that's on that curve is exactly 6 centimeters from C. So the region that we want to shade now is less than 6 centimeters from C, so it's inside this part of the curve, and it's nearer to AB than it is to DC. So if it's nearer to AB, it's above the purple line and inside the curve. So the region that we're talking about is above the purple line and inside the curve, which is that region there. And then the final question on this paper is some algebra. Factorize 3x, take away 6. Well, I can write 6 with a 3. That's the same as 3 times 2. So factorizing is taking out of each term something that's common and leaving what's left in brackets. So I can take 3 out because 3 is in both. If I take 3 out of that, I'm left with x. If I take 3 out of that, I'm left with 2. So 3x minus 6 is the same as 3 bracket x take 2. And you can check it easily enough by multiplying it back out. 3 times x is 3x, 3 times minus 2 is minus 6. I know that's right because I've checked it. Nth terms, we've done plenty of practice on these. Find the difference to find out what n rule it is. This is going up in 6s, so it's a 6n rule. Is the first term 6? No, it's not. It's 1 less. So take 1. Job done. Rearrange the formula r equals 5t takes 7 into the form t equals. So what we do is, using the laws of equations, the rules of algebra, we need to solve this equation to get t on its own. First thing we have to do is get rid of the take 7. The opposite of taking 7 is add 7. If you add 7 to one side, you have to do it to the other as well. So that take 7 is gone from that side because minus 7 plus 7 is 0, but it's on that side now. The 5 and the t are joined by a times, so I've got to do the opposite of timesing by 5, which is dividing by 5, and in algebra we write divide by 5 as over 5. So that is it. Or add 7 all over 5. So that's the end of November 11, paper 1.